Hello and welcome to In Stitches. Going old school again. This is a Singer 81K73 Overedger, or otherwise known as an overlocker or a serger, and it dates from 1940, so it's could quite easily be a companion in a factory to this machine here. I did a video on just recently, this 143 W2 zigzag industrial machine. Very similar era. I'm not too sure exactly what the date on the 143 W2 is, but I'll look that up. But this one's definitely 1940, and it looks like there was about 1,000 of them made. For most of the Singer machines, you can get date information by looking at the serial number. If we have a look down here, we can see the serial number down here for this machine, and you can look that up on the ismax.net website, and it gives you information on date and commission numbers and things like that. Pretty handy information. This machine here is basically just the head only. I don't have the table for it again, but it's one of those ones that we'll keep an eye out for a table for. This is actually a customer's machine. She wanted me to just go through and make sure it's all going well, as far as stitching at least, and work out the threading and things like that. If we have a look at the manual here, this manual covers the 81K70, K72s, K73 and K76. High speed overedger. The description says these machines make either the 2 or 3 thread overedge chain stitch and trim the edges of the goods in advance of the stitching so that the article can be shaped while it is being stitched. They are automatically oiled by means of a series of wicks which convey the oil from the reservoirs to the principal bearings. K70 variant is fitted with a gathering feed, so different differential feed on a 1940s machine, so differential feed's definitely not a modern invention, and is used for trimming and closing seams in light and medium weight knit materials and rayon. The K72 series is used for trimming and overedging flannel, muslin, denim and other similar materials, and also for rayon where a gather feed is not required. So that doesn't have the differential feed. It is used for inserting sleeves, seaming house dresses, etc., also for stitching pockets into trousers. The K73 variant, which I've got here on the bench here, is used for trimming, overedging and closing seams in light and medium weight knit materials and rayon. It has a new gather feed which can be quickly adjusted by hand to regulate the fullness of gathering on sweater material, or for rayon where gathering is not required. For loosely knitted sweaters, the knife can be adjusted to trim 5/16 inch from the needle. The K76 series is used for trimming, overedging and blind stitch hemming or welting in knitwear. It is fitted with a gathering feed. The speed of these machines is fairly impressive for the time. For the first week, run the machines up to 4,000 revolutions per minute. The second week, 4,300, and the third week, 4,500. The speed of 4,500 revolutions per minute can be maintained for long runs. So yeah, today I thought I would just go through and thread the machine up, make sure it's forming a stitch. Of course I can't run it at high speed, as I say, because I don't have the motor and the table for it. But I'll go through and we'll check things like the blade, make sure it's feeding, check the stitch length, things like that. Give it a good oil, good clean, and we'll have a little explore of this machine. We'll take some panels off and have a look at the workings of the machine as well. So these machines are a little bit before my time, quite a bit before my time actually. I started my apprenticeship as an industrial sewing machine mechanic in 1986. And of course, we saw older machines back then in the factories, probably 60s, 70s era, still going strong. But certainly nothing from the 40s. They were well and truly outdated by then. But still, I think this is probably going to be a capable little machine as a 3-thread overlocker. And yes, I will refer to this as an overlocker. I know that in other countries they're referred to as sergers. but Singer actually call it an overedger. Pretty standard fare as far as an overlocker is concerned. It turns in the opposite direction to a standard sewing machine, the likes of a straight stitch industrial machine, or your general home domestic machine will generally turn the wheel this way. There's an easy way of telling what direction a machine is designed to run in if you don't have access to the manual or you just want to quickly work it out. The easiest way to check that is to look at the feed dogs. If we have a close look at the feed dogs here, you'll see that the feed dogs will pull the material through. So the feed dogs have come up through the plate and then they drop down to come back towards the operator. So we're looking at this from the left front. If the machine's being turned in the operating direction, you'll see the feed dogs come up and feed away from the operator, so feeding forward effectively. Be careful on a standard sewing machine. Make sure that before you do this test that you've got the stitch length set in the forward direction and not the reverse direction. There's no reverse on an overlocker, so you know that you're always going to be in forward feeding motion here. You'll see if I turn the machine in the wrong direction, the feed dogs will come up and feed back towards the operator, so it'll be reverse feeding, so we know that that's the wrong direction. Probably the first thing to do would be to oil the machine before we go sort of turning it over too much like this. Not that it'll really matter too much at low speed like this. The machine's nice and free. I know it's certainly not seizing up or anything like that. But maybe let's get some oil in and have a wee explore while we're at it. Now I've got the manual, it shows you all the oil points, but I'm just going to go and oil what I can see as moving parts, and then I'll double check in the manual just to make sure I get all the oil points. But generally pretty much anything that moves, so I'll be just getting oil into parts like this little shaft here. You can see that turning there, and there's also a little bit in the back there I'll get oil into there. So that's a needle bar drive there. Better do these linkages here. Just get in behind those linkages there. Needle bar, definitely. We'll see we've got a definite oil point here spelt out. Just get that lower needle bar bushing done there. And the manual actually says to fill these reservoirs. There's actually a reservoir just here. The lid's missing. They normally have a little flip lid, so I'll show you around the front here. There's one here. It's got a flip up type lid there, just to stop any dust and foreign matter getting down into there. And the manual says to replenish these once a day. So, you'd have to assume that the machine's doing a shift a day. So probably maybe getting 7 hours of work a day. I don't know about back in the 40s whether they would have multiple shifts and whether they worked longer than the likes of an 8-hour day. But, you just sort of judge that as to how much oil it's using and keep it topped up. And then they also recommend to do these manual oil points like this one that I just did here on the needle bar every half day. So there's a fair bit of oiling to be done. I'll just fill this reservoir here. I'll just give that a little bit of a top up there. And as I mentioned before, that was in the manual there, that there are wicks that will wick the oil to the appropriate parts there, the ones that aren't manually oiled here. Not exactly sure how much to put in there at this stage, but we'll take the lid off and have a wee look at that later. Just get some of the main oiling points done. There's also a note in the manual there, a machine new from the factory or one that has not been used for some time should not be operated until about 3 hours after filling the reservoirs. Now that'll be to allow the oil to soak through the wicks, for 3 hours to get to where the dry bearings might be. And they also stay here. Failure to heed this caution may result in serious damage to the mechanism of the machine. So yeah, they're basically talking about ruining bearings and whatnot there. That's the presser foot lifter. Have a look at that. That's this here. So you can lift the foot to get the material underneath. You don't always need to. You can just feed the material in and the machine should pull the material through as it sews. But basically, get oil on that. Another linkage down in here. That one there. Yep. This is a fairly serious sort of ball joint here. It probably needs a good douse of oil there. People often ask me where I get my oilers from. Now, you can't buy these anymore new. They're not available new. But that is from an Elna Supermatic, dating from probably the 50s, somewhere around there. They made them for quite some time. Handy little oilers if you can find them. Keep an eye out for Supermatic, Elna Supermatic machines and you might find one. Yeah, I might take this off actually and just have a wee look-see under here. Let's get the plates off that I can easily get off on this machine, and we'll have a look inside and get some oil in. So I can see a screw here, screw there. Just a note about flat-headed screws. I do hear people complaining about flat-headed screws and why they were ever invented and why you would ever need to use a flat-headed screw when there's Phillips. The advantage with a flat-headed screw over the likes of a Phillips or a posi drive is that if you can't get direct straight up and down access to the screw, because of this, something like this here, is you can angle your screwdriver and get it into the flat nice and easily, and you can still turn the screw. Whereas with a Phillips, they generally only work properly if you're square onto the screw. And you can see that if I put my screwdriver square down here, it's not quite in the middle of that screw. So a slight angle, perfect for flathead screws. They're just ideal for that sort of thing. I have a hobby where I restore and mess around with retro computers. A lot of people in the retro computer scene complain about flat-headed screws, and it drives me crazy. Okay. Now, is that another mount screw? No. Just looking for where this is mounted. I think maybe this screw here holds this little cover on. Maybe. Or is that cover... No, maybe not. I want to take that cover off anyway, so... Again, I couldn't get my screwdriver exactly square on that one. Okay. Is that loose? How do we get this off? Just maybe from the front. Oh yeah, there's another screw just here. We'll take this hole. Oh, that's tight. That hasn't been undone since about 1940, I reckon. Who knows? And there, should be able to gently remove this cover. Maybe. Hopefully I can get it with a bit of jiggery pokery. Oh, there we go. We can see this cover here with the oil hole in it here and a tube coming out to lubricate probably down in this area here, I would say. And let's have a wee look in here. The other good thing about a flat-headed screw is that if the screw is extremely tight, a Phillips will tend to, when you put a lot of pressure on it to undo the screw, will tend to lift out of the slot, whereas a flat-headed screw, the screwdriver is actually more likely to stay seated in the slot properly. And so if you do have stubborn screws, flathead is a lot better, less likely to damage the head of the screw, which I like a lot. There's nothing worse than damaging the head of a screw. Here's the underside of the plate there. I was almost expecting a wick to be in here, but there isn't one. But it looks like if you fill this far enough, the oil will come down this hole here that is slightly raised. You might be able to see that there. So you do have to get a fair amount of oil in here. So I'll bear that in mind. We'll just set that off to the side there. And we can have a good look in here. And now, normally as part of a service, and you know, the likes of in a factory or whatever, you would blow this out with compressed air. There's a little bit of lint in here. It's not too bad. So basically we're just going to oil everything that moves in here. You can see here there are little oil holes for these bearings here. So, you know, liberal dousing of oil, and basically you can fill that channel there, and it's like a small reservoir there, you know. If you put a little bit too much in, it doesn't really matter. It's just going to drip down. It's generally away from the work that's being sewn, so it shouldn't contaminate the work. Okay, what else is moving here? There's another one right down in here. I'm using this oil bottle because it pumps out a fair amount of oil. I want to be reasonably liberal here with the oil. To start with anyway, that bearing there, give that a good dousing. I wonder how long it's been since it's been used, this machine. And I also wonder how long it's been since it's been oiled. So that's looking pretty good. Hopefully I get everything here. I'll try and get as much as I can here. I can also take this off here. There. Now, you do put oil down in here. There's a small sump in here, I think, but in the manual it shows that there's a little overflow bottle that attaches to the underside of the bench, and there's a hole in the bench, and the oil will flow through there. So I don't really want to go pouring too much oil in there at this stage. There is a plate under here. We'll take that off and have a wee look at that later on. And you can see a little hole here. I think that might be the overflow for it. Let's get the throat plate off here. There's a manual lift lever here, that one there. Assuming with this machine being Old English, 932. Just loosen this. Here we go. I'm assuming that will need to come right out, so they don't make it overly easy, but I mean it shouldn't really need to be removed that often. It's really only if you were adjusting the machine, I guess. Yeah, that's definitely loose there. I'm really just removing this so that you can get a good look in here, and actually that should just slide off. I've probably just loosened it a bit far. I'm just doing it quickly with the tweezers there. That should just slide by the look of it. Yeah. Oh, that's not too bad. Just needs loosening and slides off. Nice and easy. See a little bit of wear on the sole of the presser foot there. Not too bad. And then we can take this throat plate out and you'll see that the feed dogs, let's get you in close there. So yeah, in 1940 we had differential feed. Pretty cool. Pretty cool. And I can see there that it's set together. You'll see it's set together because this is your rear feed dog, this is your front feed dog, and you'll notice when I turn it in operating direction that when the feed dogs are above the plate, that the front catches up with the rear, so it's gathering the material in. We can test the blade cutting here. Be surprised if they cut well. Yeah, chewing quite badly there. Are they adjusted properly? Yeah, they look alright, but I'll look at giving those a sharpen and see how we go. But anyway, let's get this plate off. Just the 2 screws for this one. A little bit of surface rust there. Not too bad. And should be able to just swivel that off. Oh look, there's an oil wick. There's an oil wick right here. Is that an oil wick? I assume it is. Where's that oil from? Let's see. Oh, we can swing this out of the way. Yeah, I'm not too sure where that gets. Oh, yeah, through the back here, I would say. That hole there will be, yeah, I can see the oil wick down the hole there. You might just be able to see it there, but I think if that was, you know, you don't have to take the plate off to get to it. You just oil in behind there. But anyway, I'll give it a good soaking. That will be oiling this main bearing for this main shaft here, coming through. Main shaft comes through here. That'll be the oiling point for it there. I can also see another oiling point just here. Basically just going to give it a good slather. There's more oiling down here for the looper. That's the left looper. That's the left looper there. This one here, sorry, no, that's the right looper. Left looper is just here, or sometimes called under looper and over looper. Okay, let's just hit everything that moves pretty much on a machine like this. We don't have a motor nearby to worry about. That's the only thing, you know, one thing you do have to look out for when you are liberally oiling a machine is that you don't want any of this oil to get onto any of the drive belts or the motor, anywhere near the motor or the electrics. But on a machine like this, there's no motor, there's no electrics, there's no drive belts. You could dunk this machine in a bath of oil and not damage it at all, as long as you've sort of semi-dried it off, I guess, before you used it. It'd be fine. But yeah, you could completely soak this thing. A little bit of lint under there, a little bit of surface rust there, nothing too major. In fact, if you've seen the previous video on the 143W3 W2, sorry, over here, that in the jar is evapor rust, that stuff there. And it's been soaking for days because I haven't quite got back to this machine here. And you know, I haven't really fully soaked this, but that was dipped in the evapor rust there. It's in pretty bad shape. This plate is rusty as anything. I had it dipped, I think this portion here in the evapor rust just for a little while. But you know, I'd have to give that a good soaking, I think. Yeah. what I'll do is I will soak that in the evaporust, see if it comes up any better. But in the meantime, I'll put it back on later on, and I just want to test the machine and show you if it's working or not. More oil points, I think. No, that's a screw hole. Yeah, a couple of, I got to those decent ones down there. There's a couple of linkages in the back here. Sorry, you might not be able to see that. A couple of linkages in here. Just give that a quick blast. Maybe here, there. Actually, this here can come off, I'm sure. I was having a wee look at this earlier, and I'm just not too sure whether this plate here is original or not. Don't know. Just looked out of place. I'll take that off there, and that will allow us to remove that other plate. They just need loosening there. Yeah, this looks like, you know, it's been, oh no, it's got a Semenco part number. Yep, okay, well, it's original then, I would say. That plate can come off, that's loose now. That one can just slide out. There is supposed to be another screw here, but it's missing. We don't really need to, in fact, let's just leave that on. I should be able to slide this past it there, like that. That's the other plate there. And then we can see right in the front of the machine there. This is a spring-loaded knife here. I'd like to oil that shaft. Nice and smooth there. And I'm not sure of the state of this needle either, but it is a reasonably common needle. I think it's an 81X1 needle. I'll double check that in a second. But yeah, I think that's got the majority of the working parts oiled. Let's just flip it over. I'm curious about this, what's under this plate here. I'll just undo these screws. I'll jump cut so you don't have to watch me undo 7 screws. Now, I'm hoping this plate comes off easily. Hopefully it's not stuck on there. Let's remove these here. Nice and easy. Oh yeah, so here's our oil wicks, right. Oh yeah, so that is not a drain plug. I just assumed it was. There's a little bit of lint here. This would be part of the mechanic's job in the factory, maybe from time to time, is to, when the machine's not being used, or while I've got it apart maybe, just to clean some of this lint out. And everything should be oiled though if it's been well maintained, but you know, I can feel that these wicks are pretty dry. So I guess as long as that gasket around here is in good condition, it shouldn't leak any oil, but who knows. So by rights, these wicks need to be thoroughly soaked, and the machine needs to have oil sitting in the bottom so that these wicks sit on here where the oil is pooling in here. So I'll just give them a provisional oil. At least it might soak up a little bit. And if you're going to be running this machine, you know, in a factory after it's been sitting like this has been for a long time, obviously, you would need to obviously not probably go this far to take this sump off, but you know, fill this sump with oil, and then, as it said in the manual, leave it for 3 hours for these wicks to soak that oil up to the bearings where it's needed. So yeah, but because I'll just be turning the machine by hand when I test this machine, I don't think that will be a big problem. And I have manually oiled a lot of the points anyway. Okay, let's just put this back on, and I'll come back when I've screwed it all back up there. Okay, that's those tightened back up again, and let's just, I'll put a bit of oil down here, not heaps, maybe half of this here, just in case it leaks. It's going to leak all over my pillowcase here. Put a bit more in there. Okay, and that'll give the wicks a good chance to soak up a bit more oil there. Okay, right, and pretty much all I need to do is change the needle, sharpen these blades. So let's just go ahead. I'll put chapters in these longer videos so that you can skip forward if you want to. Skip, you know, if you don't want to watch me putting things back together, you can easily just select a chapter and skip it. That there, just, I don't know, this looked sort of handmade almost. This little plate here, just get those screws there. Yeah, they're a bit worn, the heads, those screws, but they don't need to be horrendously tight. Just nip them up there. That's it. Okay, and then let's put this plate here back on, swing it around, and just manipulate this back into here. Just got to try and remember how it came out. Gee. Come on. I don't want to force anything. Oh, jeepers. Maybe. Ah, there we go. Jiggle. There we go. Two screws here, one there, and is that going to line up? There we go. That's got it. Just get that started at least. When you are dealing with panels like this, it's best not to tighten the first screw up until you get all the other screws in, or don't tighten any of the screws actually, just get them started before you go tightening them. Otherwise, when you go, if you tighten a screw up and you go to put the other screw in, the hole might not line up, and you'll never get the screw started. So get those two tightened up there, and then I'll fill this little reservoir with oil. Fill it, just to remember not to tip this machine up. See there, even there it's not coming down into this hole here, so keep going. There it is, starting to flow down there now. So it takes a fair amount of oil. Oh, where's that going? It's pouring out the bottom here. Okay. Yeah, I guess you just fill it until you see oil coming out. It's no big problem. I mean, you could mop that up. It's no big deal, you know. Yeah, if you're using it in a factory, maybe, who knows. So that's the little filler plate. Just get that back in. That screw there started. And then another one out the back here. Made in Great Britain, manufactured in Great Britain. Very good quality, can't go wrong. Just everything is oozing quality. The steel is just of the highest quality. You can tell by the hardness of the screw heads and things like that, that these are extremely good quality. That's that front one done up. Okay. Actually, I might just leave the throat plate off until I replace this needle, just to see whether we're still getting that lower looper brushing the needle there, whether any adjustment is required or not. I've got my stash of needles I use in my workshop here. Certainly not going to be any of those. Domestic needles. Overlocker. I should really sort these out one day. 134Rs, DBX1s, no, B27s, B27 they're overlocker as well, but not this one. We're looking for 81X1, BLX1, that's baby lock. Jeepers, no, maybe in here. Let's just have a quick look in here. 134 leather, DBX1s, 1738s, that's it. 81X1, size 70, fairly fine. DBX1s, 135X17, 81X1, size 90, 14, we've got one of those. So I've got a couple of sizes there to choose from. We'll have a little look at what needle's in there, see what size has been in there. It is 932, again, that's handy. One spanner required to take the foot off and the needle. Okay, should be loose enough there. Yep, let's see what size this is. Hey, that's a Semenko needle, so that's an original Singer needle. Let's see if we can read the... It is Semenko. Is that a 16? Let's have a look at this 90 here. This is a brand new Smets one. This is a 90. Yeah, I reckon it's probably... well, that's a 14, the 90. Would that other one be a 16? Look at that, they are slightly different. Yeah, actually. Yeah, that's quite a heavy needle. So that's a size 100, that's the Semenko one. That's one that's come out of the machine. It's the bottom one there. And although they are the same needle system, you can see that the Smets one, the one on top, is slightly longer, just ever so slightly. But it is the correct one, so it should be okay. In fact, we can check the needle straightness here. We can do it on this bed here. That should be fairly flat. I've just put that on a flat surface there. And because that is a round shank, we can test with a screwdriver. And I can see the head wobbling. I'll see if I can get you in closer here. You might be able to detect there a wobble in that point. You see that point wobbling? Bent needle. Point wobbling there. No good. Good brand new needle. We should have no wobble. Nice and straight. Oops. That's good. Okay. Install that. Let's hold that in position there. There's no flat on the shank, of course, so you have to make sure you've got it positioned correctly. So on the needle here, you'll notice that the front of the needle has a channel running down the blade there, and that faces the front on this particular machine because you thread from front to back. And on the back you'll see the little scarf just above the eye there, just here, with another little channel above it there. So that's the rear of the needle, and that's the front there. We can have a good look at the scarf there, just there on the back. That flat surface just above the needle eye is the scarf. Okay, original Simanco needle. While I've got the plate off, actually, I think I'll remove these blades and get those sharpened up. I'll take the top blade out first. That should be loose enough there. Top blade. Good thing about these blades is they're nice and long so that you can sharpen them. And I just sharpen them on a grinder, and it should be easy enough. And then this one, the lower blade screw in the front on the left hand side here, actually, we'll loosen that one nice and easy. And the lower blade has actually got this little handle on the bottom. Pretty handy. I've never seen a lower blade with a handle on it. I guess that's so that you can easily adjust the height. But this one is looking a little bit dull, I think. Yeah, kind of hoping that this sharpening will bring these back. This video is going to be rather long, I think, if I carry on with what I want to achieve today. So I'll leave it at this point here, and I'll get these blades sharpened, and we'll come back. We'll call this part 1, and then we'll come back part 2 and finish off. So as always, thank you very much to my patrons, and thank you very much for watching.